everyone, I am Malathy from the Department of Mathematics, Business College of Engineering. Today we are going to see the topic Z transformation. Earlier I have told you that is we are having two types of Z transformations. One is bilateral, another one is unilateral. Bilateral means minus infinity to infinity, then unilateral means 0 to infinity. That is we are covering here minus numbers to plus numbers. Here we have considered 0 to positive alone. That's why we are saying this as a unilateral Z transformation. Mostly in our syllabus we are going to use this unilateral Z transformations alone. Then we should know, before going into this topic, we should know what is sequence and what is series. We are going to see the sequence as well as the series. Sequence is nothing but the collection of numbers. We can say this is also one type of series. 2, 4, 6, 8, etc. This is also one type of sequence. What sequence is this? What order is this following? Increasing by 2. So, some numbers following certain conditions now, that is sequence. The collection of sequence is nothing but series. Okay, we should know what is sequence and series. We are having some numbers by the condition. If you are following, if you are creating any pattern now, that is sequence. The collection of sequence is nothing but series. So we are going to deal with this sequence and series in Z transformations. Okay, so first we are going to do some basic problems. Before entering into the problems, we need to know what is binomial condition. Already we have seen many binomial condition in many topics. That is, we are having here 1 plus x whole inverse and 1 minus x whole inverse. Then we are having 1 plus x whole power minus 2. Then we are having e power x. These are some important binomial formulas. Using this, we are going to solve these problems. Suppose if we are having plus and minus now, we will have here 1 minus x plus x square minus x cube plus etc. If we are having both the terms are minus means we can write 1 plus x square plus x cube plus etc. Suppose if we are having plus and minus 2 means we have to write 1 minus 2x plus 3x square minus 4x cube plus etc. Suppose if we are having e power x means we have to write 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial plus etc. By using Z transformation condition as well as binomial, we are going to do some basic problems today. That is, your first problem is we have to find Z of 1 equal to Z divided by Z minus 1 minus of Z greater than 1. I have said no, we are going to see unilateral Z transformation alone in this topic because always we will have here positive condition. This Z must be greater than 1. Positive sides only we are going to concentrate. So we have to write here, first of all we have to write the formula of Z transformation. X of Z equal to summation. This is unilateral, so we have to write here n equal to 0 to infinity. X of n Z power minus n. So we all should know what we are having within this Z of something, that is here x of n. So here the x of n is what? Here x of n is 1. So we have to replace here by 1. So we have to find here x of Z equal to summation n equal to 0 to infinity 1 into Z power minus n. Now we have to increase this 0 to infinity. We have wherever we are having n, we have to give 0, 1, 2, 3 like that. Anything for 0 value is what? 1. So we can give it Z power minus 0. So we will have here 1. Then we can write Z power minus 1. Then we can write Z power minus 2 plus etc. So we can write here 1 divided by Z. 1 divided by Z square plus etc. Now what I want to know is by which formula we can convert this as a left hand side. Here we are having all positive terms now. 1 plus 1 by Z, 1 by Z square plus etc. Which formula we can use? 1 or 2? Second formula we can use. In the both the terms, in all the terms we are having here positive term. Here x value is what? This is here x value. So we have to write here x equal to 1 by Z. X equal to 1 by Z. So we can write x of Z equal to 1 minus 1 by Z whole inverse. So right hand side we can make that as a left hand side. So we can write as 1 by x, no? So if we want to cancel this inverse, so we are taking here reciprocal. So z divided by z minus 1. So here x of z here is z divided by z minus 1. Z is greater than 1. That is the thing they have asked to prove. We have done it here by using the z transformation formula. Yes. Few more problem also we are going to solve today. That is. So as we completed this problem, we can't do many more problems in next classes. Thank you all.